Hi, I'm Don Dawson. This program is the second program in a two-part series on electrocution hazards in construction environments. The series covers information on electrical hazards and electrocution, major types of electrocution hazards, power lines, GFCIs, power tools and extension cords, lockout, tagout, and isolation, assured equipment grounding conductor programs, and employee training. As we've discussed in part one of this series, construction sites can contain a number of potential electrical hazards, and OSHA requires employers to do as much as possible to protect employees on a site from those hazards. Let's quickly review the types of hazards that we might encounter on a site. OSHA defines 4 types of hazards that are associated with electricity and 3 types of injuries that result from them. Direct contact with electricity through a power source, cord, or transmission line is the most common type of electrical hazard and can occur in a number of ways. Fires are a common result of electrical problems. Most often they occur as a result of faulty electrical outlets and old or damaged wiring. Problems with power cords and extension cords, plugs, receptacles, and switches can also cause electrical fires. Explosions are another potential result of an electrical malfunction. An explosion can occur when electricity ignites an explosive mixture of material and air. This can range from a liquid such as gasoline to something as common as dust. Arc flash is one of the most intense forms of electrical hazards. It is the sudden release of electrical energy through the air when a high voltage gap exists and there is a breakdown between conductors. An arc flash gives off thermal radiation, heat, and bright, intense light, both of which can cause burns. Temperatures as high as 35,000 degrees Fahrenheit have been recorded from some arc flashes. High voltage arcs can also produce significant pressure waves by rapidly heating the air and creating a blast. Shock is the most common result of an electrical hazard. It occurs when the body becomes part of an electrical circuit as electricity enters the body at one point and leaves it at another point. Burns are another electrical injury that occur frequently. Burns caused by electricity can be one of 3 types. Arc flash, the most serious, caused by an electric arc or explosion. Thermal contact, intense radiated heat. This often occurs when the skin comes into contact with overheated equipment. Electrical, resulting from the heat that is generated from the flow of electricity through the body. Electrical burns occur when an electric current flows through tissue or bone, generating heat that causes tissue damage. The body cannot dissipate the heat generated by current flowing through the resistance of the tissue, and as a result, burns occur. Electrical burns of any type are among the most serious types of burns and always require immediate medical attention. Electrocution is the most serious result of coming into contact with an electrical hazard. It occurs when someone is exposed to a lethal amount of electrical energy and is by definition fatal. Typically, the electricity interrupts the rhythm of the heart and ultimately causes it to stop beating. Over the years, electrocution has become the 4th leading cause of death in the construction industry. Builders and contractors must do a number of things to protect their employees from electrical hazards and electrocution. If work is being done around overhead power lines, the employer must see that the lines are de-energized and grounded by the owner or operator of the lines, if at all possible. If power to the lines can't be cut off, the contractor must make sure that workers maintain a safe distance from the lines and that they use protective equipment and tools, such as rubber insulating gloves, insulated hoods and/or sleeves, matting or blankets, line hoses, insulated hard hats. Other protective measures such as guarding the power lines or installing insulated sleeves can also be used. Employers are also required to train workers regarding power line hazards and the protective measures that are being taken or are available to them. Workers must be fully informed about which of their jobs may have power line hazards associated with them and the measures that they should take to control the hazards. Procedures need to be put into place so that workers can get answers to any questions that they have about working safely around power line hazards. Another responsibility that employers have is to make sure that electrical parts, outlets, and power supplies are controlled and protected appropriately. Parts, wiring going into circuit breaker boxes, and cabinets and fittings should all be protected from abrasion. Openings through which wires enter circuit breaker boxes and cabinets must be effectively closed around the wires themselves. Likewise, unused openings in cabinets, circuit breaker boxes, and fittings must also be closed off. Employers must also ensure that all fittings, circuit breaker boxes, and pull boxes are covered. Metal covers must be grounded. In energized installations, each outlet box must have a cover, faceplate, or fixture canopy. Covers of outlet boxes that have holes for flexible cord pendants must include bushings or have smooth, well-rounded surfaces for the cords to rest on. As we've discussed, ground fault circuit interrupters also play a big part in electrical safety on construction sites. If possible, employers should have GFCI circuit breakers installed in all circuit boxes and cabinets that are not part of the permanent wiring of the structure that is being erected. Otherwise, GFCIs should be installed in all receptacle outlets. If, for some reason, GFCIs can't be used on a job site, an Assured Equipment Grounding Conductor program can be implemented. This program must be implemented by a competent person, designated by the general contractor or builder responsible for the project. The program must be designed so that all of the electrically powered tools and equipment on the site have some type of grounding protection. It must cover all receptacles which are not part of the structure that is being erected, equipment that is connected to electrical power by cords and plugs, as well as the electrical cords themselves. Receptacles on the ends of the extension cords must also be protected by GFCIs. In this way, either all of the sources of electricity on the construction site will be grounded, or if the sources aren't grounded, all of the tools and equipment that are plugged into the ungrounded sources will themselves be grounded. OSHA requires that a written description of the AEGCP be kept at the job site. It should outline the specific procedures that have been adopted, including those for conducting the equipment inspections and tests that OSHA mandates. Test schedules should also be documented. All tests must be recorded, and the records must be maintained until the next set of tests is conducted and new records are created. The written AEGCP description and test records must be made available at the job site, to any employee who is working on the site, as well as to OSHA personnel. Any equipment that is part of the Assured Equipment Conductor Grounding Program must be visually inspected for damage or defects before each day's use. Damaged or defective equipment must be removed from service and repaired before any employee uses it. OSHA requires two types of tests to be run on the equipment and receptacles that are part of the AEGCP. The first is a continuity test to ensure that the equipment or receptacle is grounded on a continuous basis. This test must be performed on all extension cords, cord sets, and receptacles that are not part of the permanent wiring of the structure that is being erected. Any equipment that is connected to an electrical power source via a cord and plug must also be tested. This test may be performed using a simple continuity tester, such as a lamp and battery, a bell and battery, an ohm meter, or a receptacle tester. Additionally, each receptacle, attachment cap, and plug on the job site must be tested to make sure that they are correctly attached to their grounding conductors, and that the grounding conductors themselves are connected properly to their terminals. Another thing that employers must do to ensure that everyone on the job site can work safely with electricity is to see that any power tools that are being used on the job site are maintained in a safe condition, and that power supply systems, electrical circuits, and electrical equipment are all grounded. Any exposed metal parts and equipment that is on the site must be grounded as well. All of the systems must be inspected frequently to ensure that their paths to ground are functioning correctly and continuously. Employers must ensure that any workers on the job site understand that it is their responsibility to inspect the electrical equipment they're working with before they use it. Workers must understand that ground prongs cannot be removed from tools or extension cords as well. Employers must also make sure that all electrical equipment that operates at 50 volts or more is effectively guarded so that workers do not accidentally come into contact with live parts. This equipment should be placed where it is accessible only to authorized workers who are qualified to work with the equipment. Guarded locations can be a room or vault, a balcony or gallery, or any site that is elevated 8 feet or more above the floor. Sturdy permanent screens can also serve as effective guards. A particularly important responsibility that employers have is to train all of the workers on the job site regarding electrical safety-related work practices that pertain to their job assignments. These include de-energizing electrical equipment before inspecting or repairing it, using only cords, cables, and electrical tools that are in good condition, recognizing situations where lockout-tagout procedures must be used, and knowing when personal protective equipment should be worn when working with electricity. Employers must also make sure that all workers on the job site know how to use proper lockout-tagout procedures, including which controls need to be deactivated while equipment is being worked on, which de-energized equipment or circuits need to be locked out and tagged, and where locks and tags should be placed. That tags must plainly identify the equipment or circuits that are being worked on. Lastly, OSHA requires that employers ensure that the flexible power cords and extension cords that are used on their job sites be rated for hard or extra hard usage, as determined by the National Electrical Code. These ratings must be indelibly marked on the cords, approximately every foot along the length of the cord. Codes that are commonly found on cords indicating that they are suitable for hard service include S, ST, SO, and STO. Cords indicating junior hard service include SJ, SJO, SJT, and SJTO. All extension cords being used on the site must be 3-wire cords so that they can be grounded and can facilitate the grounding of any tools or equipment that they are connected to. Watertight or sealable connectors should be used with all tools, cords, plugs, and receptacles to limit their exposure to excessive moisture. As you can see, there's a lot employers are required to do to protect you from electrical hazards that you may encounter on a job site. Let's review. Power lines must be de-energized, grounded, or guarded if possible. Electrical parts, outlets, and power supplies should be controlled and protected. Ground fault circuit interrupters, GFCIs, should be installed in breaker boxes or receptacle outlets if possible. If GFCIs can't be used, an assured equipment grounding conductor program must be implemented. Power tools and other equipment must be grounded and kept in good condition. Workers must be trained in lockout-tagout procedures, and locks and tags must be available. Electricity can be dangerous, and employers are required to do a number of things to help protect workers from electrical hazards and electrocution. But it's important for us to do our part as well, so that we can go home injury-free every day.